Hello and welcome to Technological News.
Today's topic: innovative 3D printing technology creates glass microstructures with rays of light. Researchers at the University of California, Berkeley have developed a new way to 3D print glass microstructures that is faster and produces objects with higher optical quality, design, flexibility, and strength, according to a new study published in the journal Science. A 3D printed trifurcated microtubule model. Working with scientists from Albert University of Freiburg in Germany, the researchers extended the capabilities of 3D printing process they developed 3 years ago. Computed axial lithography to print much finer features and to print in glass. They dubbed this new system MicroCal. Glass is often the preferred material for creating complicated microscopic objects, including lenses and compact, high-quality cameras used in smartphones and endoscopes, as well as microfluidic devices used to analyze or process minute amounts of liquid. However, present manufacturing methods can be slow, expensive, and limited in their ability to meet the industry's increasing demands. The CAL process is fundamentally different from today's industrial 3D printing manufacturing processes, which build up objects from the layers of material. This technique can be time-intensive and result in rough surface texture. CAL, however, 3D prints the entire object simultaneously. Researchers use a laser to project patterns of light into a rotating volume of light-sensitive materials, building up a 3D light dose that then solidifies in the desired shape. The layerless nature of CAL processes enables smooth surfaces and complex geometries. This study pushes the boundaries of CAL to demonstrate its ability to print micro-scale features and glass structures. When we first published this method in 2019, CAL could print objects into polymers with features down to about a third of a millimeter in size, said Hayden Taylor, principal investigator and professor of mechanical engineering at UC Berkeley. Now with MicroCal, we can print objects into polymers with features down to about 20 millionth of a meter, or about a quarter of a human's hair's breadth. And for the first time, we have shown how this method can print not only into polymers but also into glass, with features down to about 50 millionth of a meter. To print the glass, Taylor and his research team collaborated with scientists from Albert University of Freiburg, who have developed a special resin material containing nanoparticles of glass surrounded by a light-sensitive binder liquid. Digital light projections from the printer solidify the binder, and then the researchers heat the printed object to remove the binder and fuse the particles together into a solid object of pure glass. The key enabler here is that the binder has a refractive index that is virtually identical to that of glass, so that light passes through the material with virtually no scattering, says Taylor. The CAL printing process and this glassometer developed material are a perfect match for each other. The research team, which included lead author Joseph Thoms, a PhD student in Taylor's lab, also ran tests and discovered that the CAL printed glass objects had more consistent strength than those made using a conventional layer-based printing process. Glass objects tend to break more easily when they contain more flaws or cracks or have a rough surface, said Taylor. CAL's ability to make objects with smoother surfaces than other layer-based 3D printing processes is therefore a big potential advantage. The CAL 3D printing method offers manufacturers of microscopic glass objects a new and more efficient way to meet customers' demanding requirements for geometry, size, and optical and mechanical properties. Specifically, this includes manufacturers of microscopic components, which are a key part of compact cameras, virtual reality headsets, advanced microscopes, and other scientific instruments. Being able to make these components faster and with more geometric freedom could potentially lead to a new device function, a lower cost product, said Tyler.